Hi, my name is Dan Rosnova. I'm a Principal Program Manager in the Azure Hyperscale Compute team. I'm here today to talk about Service Bus Premium Messaging and Messaging at Scale. Our agenda for today is to cover three broad areas. The first is what is Azure Messaging or Service Bus? What is Premium Messaging and why do you care? And what do you need to consider for scale and reliability when working with messaging? Firstly, let's look at the tools that are inside the Service Bus box. We have three main services: Event Hubs, which is very much like a logging service like Kafka; Messaging, which would be an enterprise messaging equivalent like MQ Series or Tibco; and Relay, which is a hybrid cloud connectivity service. Today we're going to focus on messaging. When we look at what people do with messaging, it's actually a very diverse workload. So people using messaging in Azure right now do things as different as workflow, as load leveling and balancing, scheduling, delivery, claim checks and routing. Really, anytime that you're connecting different cloud services or building scalable distributed applications, you're using something like messaging, like queues and topics, to help you accomplish all these things. These are just a few of the patterns that are commonly used in messaging today. When we look at how much messaging people are doing with our services, we get some pretty big numbers. Right now, our monthly volume on messaging is at 350 billion operations a month. We have 1.8 million active queues and topics. Our daily data volume is above 295 terabytes. Our monthly data volume, since messaging solutions usually get rid of data quickly, is about 22 terabytes or petabytes. We are running at a clip right now at about 2.25 trillion events per month through the Event Hub service, and 3.2 million requests per second, average 24 hours a day, with 50 millisecond latency on all of the ingress to our services. So we're talking about some big numbers, some high scale, some very fast scale, and this is the type of workload that messaging is made for. Now I want to talk a little bit about premium messaging and why premium messaging is important for these important fast workloads. When we look at the landscape right now, what we've had up until this point are three different ways you could work with Service Bus with our messaging platform. One was on-prem as a Windows server, one was in the private cloud as part of Azure Pack, and our standard offering, which is in the public cloud, so that would be Service Bus in Azure. Well, that's a great offering. What we've realized is that people want more offerings. They want more control. They like some of the aspects of infrastructure as a service and some of the reliability they get from their own data centers. This is why we've introduced premium messaging, which also runs in the public cloud, but uses a lot of those aspects similar to IaaS. At a high level, this is what Service Bus's messaging architecture looks like. We've got a series of front-end machines, which are stateless communication servers. We've got back-end machines, which are stateful and hold your workload, and they talk to SQL Server in the back. So when you're using Service Bus, you're really doing something that looks like this. You're connecting your data through the broker and into SQL. We're getting a lot of really good stuff out of this. This is all using Azure services. It's stuff you could use yourself. This architecture gives us replicated storage. SQL Server gives us 3 backups or 3 copies in every region where we're running. We also get recoverability from being a PaaS-based service, so worker or machine recoverability. This is really PaaS. There are no VMs that we run. We don't have to install OS updates or security updates. And the front ends for this are totally stateless. So they can be dropped out when they're having any problems or communication or memory pressure. But it's not a perfect system. This is a shared platform. It's a multi-tenant platform, which is really how we started our cloud platform. If you look at how workloads are distributed across it, each workload, depending on the patterns we looked at earlier, whether it's fan out or transaction-based or sequencing, takes a different amount of resources. And those are the different shapes on this diagram. Some are small amounts of resources, some are large. And occasionally you get some that are what we call as a noisy neighbor. This is the one who shows up to the party and takes everything that's there. And this type of workload will produce pressure on our platform that will affect other people on the platform, both on the back end, so our compute layer, and also in our storage layer, which for standard and basic Service Bus is SQL Azure. This can result in latency for your solutions. I mentioned the 50 millisecond number. People get pretty used to that, and when they don't get it, they're actually a little bit surprised. But this is a shared platform, and it's a best effort in our very low cost, very low priced basic and standard packages. The premium model looks a little bit different to this. There are still front ends and back ends, and we've got a service fabric ring tying the back ends together. But what's different now is that we've actually replaced the storage engine of SQL with a more fine-grained storage engine that we call Jetstream. It's the same storage platform we use for Event Hubs, which does a tremendous amount of scale, something we've been working on a long time. When you look at how this runs in production or at runtime, your workload is actually carved out on individual machines, isolated as compute resources, so memory, CPU, and storage IOPS, dedicated completely to your workload. It's still a platform hosting many services, but now they're not using a shared pool. It's isolated pools of resources. And this is really the core of what premium messaging is. Some of the benefits here is that you're getting everything that you love about IaaS. People like IaaS because they get strong isolation for workloads. It's very predictable and easy to scale. They know that one busy workload isn't going to damage another one because they're strongly separated between machines. It's a fixed capacity that's predictable, easy to understand and work with. But there are some things that aren't so great with IaaS that are much better with PaaS. And these are things like fully managed service, no upgrades for OS or software or security. These are the things you get from a PaaS service like Service Bus. And Premium Service Bus is no different. You don't have to patch the OS. You don't have to manage the service itself. We do all of that. But you do get the type of isolation you're used to from something like an IaaS solution. And then there are other things that people like about Service Bus messaging, so standard and basic, that you also get. So it's the same SDK and features. You work with Service Bus Premium the exact same way that you do with standard and basic. It's a storage engine that people know from Event Hubs, and it's got a global footprint that our service already uses. So we are in every region. You can use our services in every region, and premium messaging is coming to every region. Beyond that, though, it's also giving us a new platform to try new features out on. For instance, we're rolling out right now larger message support, and we'll continue to grow that message size over time. And all of the new features that we're developing will be new features first in Premium. And not all of them will make it out of Premium, but Premium is really our focus for our high-end, dedicated platform for people working with messaging in the cloud. The messaging model is a little bit different. The pricing model for premium messaging is a little bit different. Instead of charging for operations, we actually switched to a concept called a messaging unit. A messaging unit describes a certain amount of dedicated resources. Again, as I mentioned before, these would be CPU, memory, and IOPS. At a namespace level, you choose how many of these resources you want, so how many messaging units you want to have in your namespace. Right now, you can choose 1, 2, or 4. They scale linearly, and a single workload can span multiple message units. So you can have one large queue or 100 small queues, and it can shuffle the workload across the entire set of message units. We've also simplified the pricing model. Pricing here is a daily meter. It's $22.26 a day, US dollars. It's a very simple model compared to our other model. And as I mentioned before, it's selected at the namespace level. So you can have many premium namespaces, and you can actually mix and have some premium namespaces, some non-premium namespaces, and choose to put your workload where you think it ought to be for reliability and performance reasons. Looking a little bit deeper at pricing, we can see that the standard and basic pricing model on top, it's actually the standard one on top. There are a lot of dials here. You have a base charge that you pay. You pay for connections after a certain point, and that actually becomes a tiered price after that, so the price gets lower. And then you also pay for messaging operations. So this would be sending something to a queue, reading something from a subscription, those types of operations. Here again, you get some amount included in a standard offering, and then you pay beyond that. And it's graduated price, so it does come down. But when you look at the pricing model for Service Bus Premium messaging, it's a very simple, easy concept to get your head around. You get a container that can do so much work, and you're free to put whatever work you want in that, as much or as little, and you pay a fixed daily cost. We are not only trying to give fixed, repeatable performance, predictable performance, we're trying to give predictable pricing too, so it's easier to make long-term investments in our cloud platform. Now I want to talk a little bit about messaging at scale, and some of the things you need to know about working with our messaging services, whether they're premium or standard, or even basic. There are a few things you need to be aware of when you're looking to scale with a messaging solution. any cloud messaging solution, really. The first is throttling. All services that are multi-tenant, and even ones that aren't multi-tenant, are going to throttle a workload at some point. It's when you're demanding too much capacity, when you're sending too much or reading too much. It's really when you're exhausting the resources in the pool. Throttling in basic and standard service bus happens both at the customer level, which would really mean your namespace. That's how much are you doing, and also at the cluster level, or on our side, which is how much we as a service are doing. So it may not be the same throttling limits at all times, and we try to be more generous than less. So we're very, very forgiving when we're not busy. We'll let people push our service very, very hard. And when total aggregate capacity is under demand, under high crunch, we won't let people push quite as hard. So it's not a consistent throttling model. Importantly, everyone will get throttled. It's a fairness-based approach. So you really need to know that if you're going to be scaling, if you're going to be sending a lot, if you're not in premium, the way that that workload performs will actually be different depending on the time of day, depending on how much you're sending, how much other people are sending. So really it's a shared pool, and keep that in mind. The next topic is retry. Retry is an important thing to understand. The cloud is not just a big private data center. It's a very large distributed platform. It's going to have different characteristics than you might get in a private data center or in a small single location. First and foremost, all of our clients include a retry policy. So all of our .NET clients for Event Hubs and for Queues and Topics will implement a default retry policy. This is a very useful feature. It makes it so that most of the time, even if there's a network blip or some small thing on your network, our network, or on the internet, you won't even see that there's been an issue. But a retry is happening. The specifics are that it's a 10-time retry policy over a 60-second window with an exponential backoff. What that really means is that the first retry is going to happen almost immediately. And then the retries will take longer and longer and longer as they retry. Eventually, you'll hit a 60-second timeout window where we'll throw an exception. So you need to be aware of these. As I mentioned, automatic retries for throttling events will take place, and any other sort of transient error. Errors that can be fixed, and the exception will actually have a property in it that tells you if these are transient or not. But most of the time, you'll never see this exception thrown. And this is a place where people can get themselves into trouble. And that's because you must be prepared for when the retry expires, which may not happen for a very long time. You could be in production for months or years before it happens. But at some point, you will hit a point where you're not able to send in that 60-second retry, and your code needs to decide what to do then. Options might be to stop sending, or to send somewhere else, or to buffer locally for a little while. So really having a strategy here is something you need to be able to do to scale. Otherwise, you end up in a place where you're just not sending messages at all, which is probably not where you want to be. And speaking of that ability to cope with outage or retry or anything like that, the last area here I really want to address is multi-region configuration. And again, this goes for all of our services at every tier, whether you're using basic, standard, or premium services. We are in every region in the world right now for Azure, and you should always pick at least 2 regions to set up your solution in. Always, all the time. Even if you're not going to use the other one, we don't charge in basic and standard for namespaces, so it's a good idea to have more than one as a backup. You should be able to change your solution very easily to switch between connection strings for the 2 regions. This is something that you'll have to do if there's ever a disaster, or if you feel like moving your workload from one geolocation to another. So you should design your solution to do this. And you'll have to think about if you might want to do an active-active versus an active-passive configuration. Which you choose to do here is really entirely up to what you're trying to accomplish and your level of tolerance for failure. Active-passive, so a failover type service, would be good for most customers. Some customers, especially customers doing very demanding or very important workloads where you can't afford to lose anything, should really look at an active-active solution. This is what our internal customers here at Microsoft do the most. They do it very well. They are aware if there's a failover, but it doesn't really hurt them because they're using a dual active pipeline. So messages go to multiple locations and get processed, and the downstream processing is made idempotent, so it's safe to happen more than once. We have some good videos on our website about how to think about this type of architecture and pick which one's the best for you, both for Event Hubs and for messaging. The next things I want to talk about have to do with scaling with Azure. So not just availability, but the characteristics of scaling at a bit more technical level of how we use our clients. The first is to always use AMQP if you can. All of our clients support AMQP, and most of our services also support HTTP. AMQP is the Advanced Message Queuing Protocol. It's an ISO, OASIS, and IEC standard. It's not just something Microsoft made up. We're part of that standards body. And it's a binary protocol. So it's a protocol that was made for messaging, hence the term messaging being in its name. This is a protocol that's tuned for this type of workload, whereas HTTP was not made for messaging. So although people are comfortable with HTTP, its biggest problem is that it's a request response protocol. 1.0 and 1.1 of HTTP require request and response. So you really have to block until you get that response. This is not the case with AMQP. It's a multiplex bidirectional protocol. So you can actually get a lot more density out of your connections. So if you can, you should always use AMQP. Speaking of connections, it's important to understand what those connections really are. If you look at our brokered connection charge in our pricing page that was on earlier, what that really means functionally is a socket, a TCP socket. So that's kind of the connection layer there. But within our services, you can have one socket multiplexing many clients. So in AMQP, these are called links. They're on a session. Session would be the same as the socket. And the links are used for the individual clients like the Queue client or the Event Hub client. So think about how you want to approach density in your solution, and the connection itself is one thing. The clients talking over the connection is another. And the scale characteristics of those two are something that you'll have to balance out a little bit. The first thing to keep in mind is that you want to reuse the clients as much as possible. Please don't create them in a loop. This is really going to cause you pain, and it's going to cause us trouble too. So if you create a Queue client to send a message and you're going to send more messages, just keep it as a local variable or local member and reuse it. And also consider times when you might need multiple brokered connections. It's really not that often, but TCP sockets have a maximum throughput on many networks, and you might need more than one socket. This is definitely an edge case. It's probably less than 1% of the time that customers need to do this, internal or external. But you do want to know that it's there as an option and what it means. And we have some good documentation on the webpage about how to use the messaging factories in our SDK to really get more socket density and also to spread your workload out across multiple sockets. The next area is to really use our clients efficiently. So to understand what they do and how you should use them in your solution, the first guidance here is really to always use asynchronous operations. This is really important because it gets back to that difference between HTTP and AMQP. Whereas HTTP is really by nature a synchronous protocol of request and response, AMQP isn't. So you can send many requests and then interleave the responses, or get one settlement which is a response really, for many sends. This is an important aspect for getting good scale. Anytime you're working with any of our services, always use asynchronous operations. You can still get ordered messaging, even with async. This is why AMQP is so good here. When you think about something like HTTP, you have to wait for the response for the first message before you send the second message, if you want those messages in order. With AMQP, that's not the case. The messages will go in order anyway. You just don't have to explicitly control it. So even if you want asynchronous-like behavior, you should use asynchronous APIs all the time. Also, an important thing to consider is batching. If batching is an option for you, it's probably going to raise your efficiency on your solution quite a bit. If you're always getting a collection or an array of things that you want to send somewhere, it's a good idea to put them into a batch. They'll all go together. It's atomic. They all fail or succeed together. And it'll give you a better throughput, better control of your solution, and certainly a lot better availability. So the call to action today is to try out messaging. It's anywhere in the world. Try out Event Hubs, queues, topics, and relays. Especially our new premium messaging service, which will be coming into GA soon. I have links here for both of our product pages for Event Hubs and for Service Bus. Please take a look at them.
We're always rolling out new stuff. Actually, by the time you see this video, we'll probably have some new announcements rolling out right around the same time. And again, thank you for joining me today. Please follow up with any questions on our community page on Azure.com. Thank you.